Hey guys, welcome to day 22 of the Leetcode challenge. Today's problem is actually problem number 560 on Leetcode. Subarray sum equals k, right? So you are given an array and a k value. So you need to find the total number of continuous subarrays whose sum equals k. If the array were to be something like this, then what we need to do is, say for k equals to 1, we need to find subarrays such as this whose sum equals to 1. Or arrays such as this is also 1, right? This is a 5. Okay, we have seen a similar question on day 13. So I'll show you the question and we can draw a comparison between these two questions. So this is the question which was asked on day 13. This is actually Leetcode 525. And in this actually we are giving a binary array and we need to find subarrays which have equal number of zeros and ones, right? And if we remember what we did in that question was to replace zeros with -1 and transform that question where now the question becomes find subarrays whose sum equals 0, right? Because if the sum equals 0, that means it would have equal number of zeros and ones. So it is a similar question what we have today. We just need to find total number of such subarrays and the sum equals to k, right? So if you remember in that question, what we did is, first we found out the prefix array or the cumulative array. So if you remember in that question, what we did was we found the prefix array of each of the element, right? And prefix array actually is the cumulative array for each ith position. It sums up all the elements till the ith position and the ith element for the original array. Right? I'll just modify the original array a bit for explaining my example in a better way. Let's say this is 1. Okay. Now let's construct a prefix array. Here it becomes 1, -4, 1, 5, 2, 0, and 4, right? So what you see is whenever you have prefix P1 and P2, so P2 minus P1 tells you the sum from subarray. So P2 minus P1 tells you the sum for the subarray, right? And what we checked in the contiguous array question was P1 equals to P2, which basically means P2 minus P1 equals to 0. We checked for this. Now we just need to check for P2 minus P1 is equals to K. Whenever this happens, we have such subarray whose sum equals K, right? And we need to count number of those. So what we'll do for counting purpose is, what we'll do is we'll construct a hash table where key becomes the prefixes. We add the prefixes in this hash table and the corresponding count. So prefixes become, so prefixes 1, we have count 1, right? We have -4, we have 1. Now again 1 appears, so we add it to the count here. Now while doing this, what we do is we also check if our P2, this pointer, if there exists, if P minus K exists in our hash table. If P minus K exists in a hash table, which means this equation satisfied, and whatever this P1 is, if this exists in the hash table, we have seen that prefix so many times. So what we can do is we just add those in the answer. Count of P1, right? Which means for this given P2, we have seen P2 minus K this many times previously in the prefix array. So we know that there exist that many subarrays with sum equals to K, and we add those in the answer. Okay, right. So let's code this algorithm. It's a very simple algorithm. And let us define answer equals to 0, right? And instead of storing prefixes in an array and then converting it into a hash table, I'll just use the hash table directly. Here, prefix hash, and store the count of the prefixes, right? And I'll keep the prefix as 0, right? This is the running total of the prefixes, right? So for num and nums, p plus equals to num, right? This is my running total. Now insert or increment count of p and hash, right? And what we need to do is if p minus k in hash table, then add the count to answer. So what we'll do is we'll do the adding to counter first, because it may happen that for a particular case, something where k equals to 0, p2 is actually p1. So if I increment the count of p in the hash table, then it won't give the right answer. It will overcount my combos of p1 and p2. So I'll need to be able to add the combos in the answer beforehand. So I'll do prefix hash of p minus k. And when we do this, if p minus k and prefix hash. Okay, now we can increment the count of this particular prefix. So for incrementing, I'll just get this key. If not present, then 0, and increment the count to 1. Right? Return answer. Now there is a particular cases when suppose k equals to 2 and the first element in the num itself is 2. So the subarray, the starting subarray itself is one of the answers, right? So what we need to do is, while we initialize the prefix hash, we also want to say that we have already seen a 0 prefix at position at the starting of the array, right? And what we do is we initialize the count by 1. Okay, let me try this solution and see if we have made any syntax error or something. Okay, now so let us submit the solution. Okay, success. Yes. So again, whenever you have like a subarray problem where you have to sum or multiply and check whether the subarray has certain properties, first of all, think of the prefixes or the suffixes uh, totals. That helps solving these questions very easily. Thanks again for watching, guys. If you haven't subscribed to the channel, please do, because we are posting daily solutions. We are discussing the ongoing Leetcode challenge. Like our videos if you do, and comment if you want any particular problem on Leetcode, if you want to discuss those problems in a video. Thanks again for watching. Stay safe. Bye.